Force in motion, page 42. Factors affecting gravity. A gravitational force exists between any two objects in the universe. However, you don't see your pencil fly toward the wall the way you see it fall toward the earth. That's because the gravitational force between some objects is stronger than the force between others. You observe only the effects of the strongest gravitational forces. Key concept here. Two factors affect the gravitational attraction between objects. Mass is one, and distance. Mass is a measure of the amount of matter in an object. The SI unit for mass is a kilogram. The more mass an object has, the greater the gravitational force between it and other objects. Earth's gravitational force on nearby objects is strong because the mass of Earth is so large. The more massive planets in Figure 3 interact with a greater gravitational force than the less massive planets. Gravitational force also depends on the distance between the object's center. As distance increases, the gravitational force will decrease. That's why Earth can exert a visible gravitational force on a pencil in your room and not on a pencil, or pencil in your room and not a pencil on the moon. So gravitational attraction depends on two factors. We talked about that, mass and distance. Suppose there was a solar system that looked like this. Use the diagram below to compare the gravitational force between different planets and their sun. Assume that all planets are made of the same material. So a bigger planet will have more mass. Looking at this, we have 1, circle the object, in the outermost orbit that experiences the greatest gravitational pull from the sun. Well, here's the outer orbit. Would it be the smaller one or the larger one? If the mass for the bigger ones have more mass, it would be this one. So this one needs to be circled. On to planet B's force. Arrow. Planet B's force, arrow from the sun's gravitational pull, should be longer or shorter than the arrow from planet A. So looking at planet A's arrow, should this one be longer or shorter? Here's the sun. It's further away. When it's further away, the force will be less. It'll be shorter. And number 3, draw what a planet would look like if it was the same distance from the sun as planet C, but experienced a smaller gravitational pull from the sun. In that, if it's a smaller one, the mass would have to be smaller if it's the same distance. So something like that would be considered. Okay.